Alright, let us go ahead and look at the code for the LCD. Now, before we go ahead and look at the actual code, what I would rather do is look at the organization of the code here. So, in all the tutorials that we follow, there will be multiple files that make up a project. Now, what you could see here is the main file will have the initial code, and depending on the peripheral that we have been interfacing, we will have a separate file for that, like say LCD in 8-bit mode for instance. So this file, if you could look through, this will have all the functions and all the details that are required to make the 8-bit mode work. Now you could observe that there are two file groups. So one has all the C source files and the other has all the header files. Now except the main file, the other two files have the header file. So delay.c, again we used it before in the first tutorial. It simply generates delay in microseconds, milliseconds or seconds as required. Now we have a function prototype for it. So the best way to get started is to look at what functions are there in the library files. So the delay, it generates microseconds, milliseconds and seconds. So for the above two, the inputs are integers, and the last one, the input is unsigned char. Now similarly for the LCD, we have LCD 8bit.c as the main C file and lcd.h as the header file. Now in the header file, we have all the function prototypes or all the functions that we have for the LCD. So basically, as discussed earlier, LCD init, it initializes the LCD. Command write, it writes a character to LCD. Command write, it writes a character command to the LCD. Data write writes the actual data, and then this is a function to clear the LCD. Then go to line 1, line 2, then go to XY as discussed. Then this particular function, it displays a string, so it takes string pointer, and then the next is it scrolls the message if there are more than 16 characters, and if you point this string to this function, then it scrolls it. Then displaying numbers, so the decimal numbers need to be converted into hex, and that's why there's to ASCII, and that's why there's a function to display numbers. Similarly, if you're interfacing RTC, RTC time needs to be in a specific format, and as well the date. So these are all the functions in the LCD library. Now if we look at the schematic, so we have looked at the schematic, and we know that the LCD is connected to port 2, the data bus is connected to port 2, and the register select in read, write and enable pins are connected to port 0, 1 and 2. So that we need to define first before we go ahead and do that. So this is done in order to make it easier. So if you want to port this code to any other ports of the LCD, you can simply change it here. So the data bus is the actual data bus for the LCD. Register select is port 0.0, then read write is port 0.1 and enable is port 0.2. You could also observe that the data type for this is S bit, which takes only 1 bit of memory. So moving ahead, what we have is a few constants. So LCD, there's 2 lines and there are 16 characters, and line 1 it starts with 80 and line 2 it starts with C0. The answer for that would be in previous video. If you have seen this, you know why it is 80 and what is C0. So this is the basic. If you want to use the library, you just need to change the port definitions here and you'd be ready to go. But let us look at the functions. So we need to send enable pulse in order to latch commands or data. So this is a simple enable pulse. We have written it as a separate function because it is used many times. So this ensures that it is low, then enable pin is made high, and the pulse width should be 230 nanoseconds, but we have made it as greater than 230 nanoseconds, so microseconds, which is much greater than 200 nanoseconds. So again, here since there are different manufacturers of LCD, what we have found that some of the LCDs, they do not boot up in, or the enable pulse width should be much greater than 230 nanoseconds. To be on a safer side, we give it as 100 microseconds. So similarly, we have a function to initialize the LCD. Now if you go through the data sheet, we need to send these 3 commands to reset the LCD. Now the point here is microcontroller boots up in a few milliseconds. For 8051 it could be 4 to 5 milliseconds, but the LCD takes a whole lot of time to boot up. Now what happens is, if you write the code and you initialize the LCD in the first part, then the controller would boot up and would have already executed this code before even the LCD boots up. So LCD misses all these commands, and hence it is recommended to follow the reset procedure, wherein you reset the LCD with this sequence. So you send 303030 along with enable pulse, and you wait for specified time. So this resets the LCD, and after it resets, you set the LCD mode. So it sets LCD as 2 lines and 5x7 matrix as discussed earlier. So we keep the display on and the cursor on for the display set command, and then we clear the LCD, and then we move the cursor to the first line, first position. So with this is the basic initialization. After that, we write a function to write a command. Now as we know, register select should be 0, read write should be 0. Register select is 0, it selects the command register. Read write 0 makes it as a write operation, and we have kept the command on the data bus. So as we have defined earlier, data bus to be port 2, so the command is already on the data bus, and when we send an enable pulse, it gets latched and the command is executed by the LCD controller. Similarly, we have a function to write data to the LCD. So the only difference between the above function and this is that instead of register select being 0, it is 1 in this case. So 1 makes it select the data register. So that's the only difference. Now what happens is, we use these commands, these 2 basic commands, and build up the entire library. Now as you could see, the LCD clear function, it simply uses the LCD clear command for the LCD, which is 0 1, if you remember from the previous video. And similarly, to go to line 1, which is a constant which sends a 0x80, it sets the address for DRAM to be the first position. So similarly, we have commands to go to line 2, then there is command to go to XY character positions, so you can go to the exact position that you need. And then the commands as discussed earlier, to display a string, to display a number, and to scroll a message. So, and you could also display numbers. So this is repeated here, yeah. So this is to display date and time on the RTC. Now if you go back and look at the main command to simply display a couple of messages, it would be pretty simple. This includes, as before, the controller definition or the port definitions for the controller. This is custom defined library which is included here. You should also make separate groups and include the header file. So this is lcd.h and this is delay.h. In the main program, we initialize the LCD and then we display a string hello world in the first line. Then we go to the second line and display a string good morning. So this is pretty simple. So this is all for the 8-bit mode. So the only difference for the 4-bit mode, let me just switch over to the 4-bit mode. So the entire thing would remain same in the main program. So if you look at main program, entire thing is the same, but we have included a different file for the 4-bit mode. Now for the 4-bit mode, the major difference would be, now if you look at the initialization LCD init function here, so it should be in the beginning. Yeah, so this is the LCD init function. So the first command, or the function set command which we sent to the LCD, instead of this being 3.8, it's 2.8. so it sets LCD in 4-bit mode, and then again the rest remains same. There's one more major difference, as you could note, and the two basic functions which we use and build the entire library upon, they need to be changed here. So basically the command write and the data write function. Now since we have only 4 lines out of 8, what we need to do is, we need to send whatever command or data that we are sending, it needs to be split up. We need to send the higher nibble first and then the lower nibble. So this function does it. So in 8-bit mode, what you could find is, you simply load the data bus and then you give the enable pulse after setting the register and read write. But here, instead of directly sending the data, what we do is, data or command, what we do is, like for command for instance, we send the higher nibble. So what we do is, we mask the higher nibble, we AND the command with F0 to get the higher nibble, and then we send it. When we make the enable pulse, the higher nibble goes. Now what we do is, for lower nibble, we shift it towards, shift it to higher nibble, and then we mask it again and send a high to low pulse. So this sends a command. And similarly, the LCD data write function, what it does is, it again basically does the same thing. So register select, the only difference is register select is 1. In both the cases, we send the higher nibble first and then we send the lower nibble. So, and we also uploaded the code. The code that we discussed right now, it does not include the busy flag. So if you're much concerned about the timings, and if you want to save a lot of time using the library, while using it in your programs, if the library needs to take very less time, you can go with the busy flag. Now the code for that is also uploaded on the tutorial section. You can download and you can test it. If you have any comments or suggestions, please do comment on the forums, and do share the